Hello everyone. Today I'm going to show my remote control go-kart. I'm just going to be giving a quick demonstration today and a quick kind of walk around overview. I'm not going into all the details of how every single part of it works. If there's enough interest in it, I can perhaps make some videos on how the actual code works and schematics and wiring and all that good stuff. But this go-kart was one we had to put a new engine on it. It's been sitting in the woods a long time. So just thought I'd do this as a fun project. Just has the basic features on it right now. But possibly, thinking about adding some more things, and that's why I thought it'd be a fun project, something to just kind of keep building on as it go. So first thing first is we'll look at the control box here. I already have the key switch turned on. The key switch provides power to everything. So everything is powered with this 12-volt battery. And then I have it wired through this relay here. So basically when you flip the key switch, it closes the relay and gives everything power. You flip the switch off and it turns everything off. So just a quick way to turn everything on and off. The main brains this is a Raspberry Pi 4 Model B. Underneath it is an Arduino Mega with an Ethernet shield, and then this is just a terminal block shield. This again, my idea is to expand upon this, so I wanted a quick way to wire things up and unwire. So you'll see a lot of terminal blocks where I can do that with. The Raspberry Pi runs a Python script that does most of the control. So you can control this both remotely and on board by plugging the Xbox controller directly into the Raspberry Pi. So then in that case, you don't need the wireless, you don't need anything, and you can just drive it like a normal go-kart just with an Xbox controller. Wirelessly, it works via UDP. So this is 2.4 gigahertz wireless. That antenna is up here. And talks back to another one I have, just bridges the communication across. This is the motor driver for the actuator, which helps us steer left and right. So real quick, I'll have my Xbox controller here. Right now, this is hooked to my laptop, which has got the wireless hooked to it as well. So this is happening remotely. But you see, we can steer right and left. So that's how the steering works. These relays here, if I hit the Y button on the controller, you'll see them click on and off. That is the engine shut off. So I have them wired to normally closed. So what that means is if there's no power or anything, the engine will shut off. So they actually have to be on like that for the engine to run. There's two of them because one's hooked to the Raspberry Pi and the other one's hooked to the Arduino. This relay is the only thing that's really hooked to the Raspberry Pi from a control perspective. And I did that for safety. In case something happens to the Arduino, it freezes up or anything happens, the Raspberry Pi is still capable of turning off the engine as kind of the last resort. So the Raspberry Pi always stays listening for a remote connection. So at boot up, it runs the Python script and starts listening for a remote connection. If you plug an Xbox controller in locally, hit the A button, you can take over control and drive it in remote, and then it'll ignore any remote connection. But if it loses signal for a period of, say, 2 seconds, it'll cut the engine off. For 1 second, it'll turn the throttle back down to idle and stop steering if it loses any communication. Again, I'm not going to go into all the wiring there. If you're interested, just let me know, post some comments, and I can make some videos on that. So let's step back here. Here's the Throttle Servo, which I have just with a metal rod connected to the throttle. So by using the right trigger here, I can control the throttle. I have the bumpers, right and left bumpers, set up to kind of set a limiter on it. So by doing that, you can kind of limit your speed, and it won't let you go past a certain point. And then on the computer side here, we just got another Python script running. That's the client script with the radio. That's again 2.4 gigahertz to the radio on the go-kart. And that's how I'll be demonstrating it today, is with the remote connection. One last thing we'll look at, again, just on this side to show you. Here's the Ethernet connections for the Arduino and the Raspberry Pi. Here, of course, USB where you'd plug in if you were going to drive it while seated in there. So I think that is the highlight. Let's drive this thing for just a minute and I'll show you what it does. So I'm gonna start it up here and then we'll get driving it. Let's see. Oh, you know what? I think I left the in the off position. All right. So let's test drive this. So as we get going here, real quick, the controls overview, which we've already kind of talked about a little bit, is the right trigger is the go for the throttle. The left analog stick is left and right steering. Y button is the engine shutoff. X button is cruise control. You can lock in the servo at a set point. And then RB, LB buttons. I have predefined max points for the throttle, so you can kind of prevent the throttle from going too fast. You may have noticed while I'm driving here, I'm kind of revving it up and down. Not going real fast. This thing can go a lot faster if you just mash on it. But it gets really hard to control because you may have noticed the wheels are bent a little bit and not aligned. They're kind of misaligned. So you can't drive perfectly straight, and the actuator is not super fast, so it's really hard to control this thing once it gets going, and plus it's bouncing all around really fast. So I've hit most of these trees, but that's part of it. But the other part is the depth perception. As you get farther out, it's really hard to see from a depth perception point. So, as part of that, one thing to add in the future would be a camera to stream back, and possibly. The other thing for the wheels being bent, they were already bent, but I think during my testing I might have messed them up a little more with the actuator overdriving a bit. So either limit switches or positional feedback, if somehow for the actuator and the steering probably. Obviously a brake, you might have noticed there's no brake. The brake on the go-kart does not work. So I need to look at fixing that or add in some way to brake there. And I've turned the engine off there with the Y button, so that works. So those are just some ideas. And again, this is just a project to play around with Python and Raspberry Pi and Arduino and network and send it over wireless. So something to kind of keep building little things on and testing as it go. But that's the quick demonstration there of everything. Let me know what you think. Hope you liked the video. Thanks for watching.